Yeah, comes on everyone. Sure, let's start off. Let's start off with a problem. Let's say you're combining, different substances like 100 grams of ice at minus 20 degrees is mixed with 100 grams of water at 70 degrees. Find final temperature and composition of the mixture. Composition meaning how much ice is there and how much water will be there. Get this. Let's say same question. What if the water is at 100 degrees? Let's do these two questions. Give it a try. I'll show you one and then you can do the second one. The first one, you are combining 100 grams of ice at minus 20 is mixed with 70-degree water. Second case, you are mixing with 100-degree water. Find the final temperature and the composition of the mixture. One. Anika. 25 grams, 125. क्या बोल रहे हैं अर्जुन? If you mix 100 and 100, your water became 150 for some reason.
Oh, sorry.
Someone created 150 degrees. How to do these kind of problems? Let me show you one. See, these kind of problems, right? Whenever you're mixing ice and all this stuff, there is a problem with the composition. We don't know whether the ice is completely melting or not. So these kind of problems, generally, this is how I handle it. See, I'll show you one. So we have 100 grams of ice at minus 20 degrees. 100 grams of water at 70 degrees. So we will do what? We will assume a common state. Assume both of them are reaching 0 degree water. We don't know, right, what is happening exactly. So let's start with an assumption. So in order to reach 0 degrees, what will happen? This guy will directly not become 0 degree water. First, it will become 100 grams ice at 0 degrees. Then it will become 0 degree water, agreed? So in this process, the heat will be ms delta T 100. Specific heat of ice is half. Change in temperature is 20. So you require 1000 calories to go from minus 20 to 0. And here your ice is melting to water, so m into L. This is 100 into 80. That is 8000 calories. Now from here to here, it will cool down. So heat will be released. We are using ms delta T. This is 100, this is 1, and delta T 70. 7000 calories. So at the end of the day, if you take a common state, this is what you have. You have 200 grams of water at 0 degrees, and the total heat will be 7000 heat is released. You absorbed 1000 heat to reach 0 degrees, and you absorbed 8000 to vaporize. So we have minus 2000 calories. Is this making sense? So the question has become like this. I have 200 grams of water at 0 degrees, and you have minus 2000 calories deficient. What is the meaning of this? From 200 grams of water at 0 degrees, you're removing heat, right? If you remove heat from water, what will happen? The water will freeze. Water will become ice, isn't it? Since Q is negative, it implies heat will be removed from water, freezing it to ice. So for 2000 calories, how much ice will form? So we are using Q is equal to MLF. So for 2000 calories, this is M into 80. This is 25 grams of ice. That means the remaining 175 grams is water. And the final temperature at 0 degrees. Have a look at this. Is this making sense? Since we don't know whether the ice will melt or not, since you have no idea what is happening, always assume a common state. So bring both of them to 0 degree water. This guy will absorb 9000 calorie. This guy will release 7000 calorie, meaning you have a deficit of 2000. That means all the ice didn't melt. Isn't that what it means? Suppose if I got exactly 0 here, what does it mean? What I assumed was right. Isn't it? What if this was plus 2000? Means I got extra heat 2000, right? So this 200 grams of water will boil, isn't it? Ms delta T. That will be 2000 calorie. So in that case, delta T will be 10 degrees. If you have a positive heat, use that heat to boil the water. Any doubts on this page? Now, if you got this, can you do the second part when the water is 100 degrees? Same logic. Try, I'll give you a minute. Yeah, right, Anusha, you got it. Boil matlab वही है, temperature will rise. Can you do the second part when the water is at 100 degrees? If you're mixing 100 grams of ice at -20 and 100 grams of water at 100, find the temperature. Exactly same thing. I just changed the data a bit. Anyone confused with this page, please ask me. नहीं आशा, you got that wrong. Check करो एक बार वापस. Right, Adrit Lakshika. Right, Yasha. So in the second case, this guy will be 100. This will be 100. So this will be 10,000 calories. So this will be 10,000. This will be excess 1,000 calorie का extra heat आएगा plus. The Q is positive. So water का temperature will rise. So we can write Q is equal to ms delta T. Don't forget, mass has become 200, not 100. You're boiling 200 grams of water. So the final answer is 200 grams of water at 5 degrees. Clear? 100 plus 100, na? How did you get 112? 100 grams of ice and 100 grams of water. You'll have 200 only eventually. Easy? All got this? Anika, clear now? Abhinav, Adrit? Let's see one more like this. What if I mix 20 grams of steam at 100 degrees is mixed with 80 grams of ice at -20 degrees? I'm mixing ice and steam. Now find the final temperature and composition. Do this question, oh God. Do this. Let's not waste time on that. Do this. 36 degrees, 56 degrees. Yes, this was the previous question. Vidyut. Similar question, but I'm mixing here ice and water. If you can do steam and water, steam and ice, that's even more dangerous than that. So if you can do this, that you can handle. Let's try this. We have two answers, 36 and 56. Anyone got any one of them? For some reason, I feel both are wrong. Feeling though, it could be wrong. But anyone else got 36 and 56? 38. Chalo. This thing is become like Tambola, na? 38, 38. अभी और दो नंबर बोल दो फुल हाउस ही हो जाएगा. Anyone else? The paper का deadline is extended till tomorrow. Make sure to give it. You guys can see two papers, क्या? नहीं? I think एक पुराना paper है, last month का एक practice paper है क्या? You have to write the 1 hour का paper. If you can write both, that is also fine. Gods, any answers? बस तीन ही आंसर आया. What are others doing? Do it fast. So I'll assume 20 grams steam at 100 degree. 80 grams of ice at minus 20 degrees. So I will assume 0 degree water is common state. You can take anything, but I'll take 0 degree water. So first steam will become 20 gram water, 100 degrees. So you will release Q is equal to M into LV, which is 20 into 540. Then it will become 0 degree water. That is Q is MS delta T, which is 21 into 100. Please check. Definitely one of you is wrong. Who goofed up? Someone got 42. Someone got 56. I think we have two 56s. And from here, this guy will suddenly not become water. This will become first 80 grams ice at 0 degrees. I hope you took this thing into account. Then this will be Q is equal to MLF. This is 80 into, MS delta T. That is 80 into S is half. Delta T is 20. 800. Maybe 56 is right. Kya pata? This guy, then it will melt MLF. This guy is 80 into 80. 6,400. There. So end mein we have 100 grams of water, 20 grams steam and 80 grams this thing. We have 100 grams of water and the net heat will be, steam has released 10,800 plus 2,000. This much heat steam released. And this ice absorbed 800 and 6,400. ये होगा 12,800 minus 7,200. Extra heat तो आ रहा है. How much is this guy? 5,600. Yeah. Now you boil up this water, meaning 100 grams of water. So M is delta T, S is 1 and delta T, and Q is 5,600. Yeah, 56 is right, everyone. Please check where you goofed up. The final temperature is 56 degrees water, 100 grams water. See how you guys got 38, 42 and all that stuff. Something you forgot. Everything will become water. Steam is too powerful, even though it is 20 grams.
सही 2000 किधर से आया?
2020 grams of water at 100 degrees is becoming 0 degree, na? I took my common state as 0 degree water. तू क्या लिया common state?
No, so I use a different method actually. But okay, I understand.
So we
Yeah.
can do common state as 100 degrees of water.
Yes, you can do that.
ठीक
वो
है.
common state तेरा assumption है रे, कुछ भी होगा. In that case, you would have got negative.
Oh yeah.
Clear? Next thing. I think till now 3 seniors got 95 out of 100 in physics mains में. They're counting ना, आ गया आंसर क्या आ गया. Idiots only these people are. After telling so much, they still must have chemistry and K. उसका score 205, physics 95. ऐसे अभी क्या फायदा ना. There are multiple people. Paper was fine रे. मतलब 95 तो आना चाहिए. Medical people scored 80 in my class. Next one. So that's calorimetry. Next thing is kinetic theory of gases. Next thing. Now KTG, right? This thing kind of looks like your ideal gas equation. PV is equal to nRT. It is the same thing. The only difference will be we'll be doing problems of a little different thing in physics. So let's see how this goes. So we have little statements there, but it is actually kind of boring. So what we'll do a few problems and then we'll do theory later on. So let's start off with the problem. Let's say we have a PV graph. I'm sure we did something else in chemistry, but let's see. V naught, 2V naught, 2P naught, P naught, A, B, C, and D. So plot pressure versus temperature graph and volume versus temperature graph. It's an ideal gas equation. I hope everyone knows what is isobaric, isochoric. Know that stuff, right? So chalo, let's do it. I'll just brief up the theory later. So a PV graph is given, plot a PT graph and VT graph. How do we do this? I'll show you one. First thing, see. In the ideal gas equation, PV is nRT. We don't have real gases in physics. So if you take isochoric process, what is isochoric process? Volume is
Constant.
constant. So P is equal to nR by V into T. That means in isochoric process, the PT graph, isochoric process will be a line passing through the origin. So if you plot a PT graph, this is how it will be. This will be V1 and V2. Who is greater, V1 or V2? So if you see it is inversely proportional to slope, right? The higher the volume, lesser the slope. So V2 is greater than V1. Similarly, if you take isobaric process, and this will be P is constant. V is equal to nR by P into T. The slope will be nR by P. That means in a VT graph, if you try to plot an isobaric process, it will be a line passing through origin. This is P1 and P2. Then P2 will be greater than P1. In isothermal process, temperature is constant. So we have PV is equal to constant. So if you try to plot a PV graph, these will be hyperbolas. And the farther the hyperbola, more the temperature. Clear with this? Now, coming to our question. V0, 2V0, P0, 2P0, A, B, C, and D. So let's say PT graph and VT graph. Let's draw them at the same time. Look at this thing. So this is line AB, this is line CD. So here, this will be line AB, this will be line CD. Agreed? Two horizontal lines. If you look at these lines, so in a PT graph, AD and BC are isochoric. How will they look? There'll be one line passing like this, and there will be one line passing like this. So who has more volume here? BC has more volume. Whoever has more volume will be less slope. So this is BC and this is AD. So if I just finalize this graph, this is how it would look. We have one line here. We have one line here. This and this. It's not a trapezium. The sides are not parallel. These two corners will meet at the center here. And if you look at the point of intersection, this point of intersection, AD and AB intersection is A. This is, so this is A, this is B, this is C, and this is D. This is how the PT graph looks like. Clear with this? Maybe I'll just draw it a little up, so that will make it more clear. There. This is not trapezium, so be careful.
Sir, can you show isothermal graph once? Thank you, sir.
VT कैसा दिखेगा? So in VT, AB and this thing CD will be two lines passing through the center. Again, same logic. Whoever has more volume or more pressure will have lesser slope. So this guy should be AB and this guy should be CD. AD and BC have same volume, meaning volume, constant volume. BC has more volume, so this guy would be BC. This guy would be AD. There. So this also looks kind of same, but this point is A, this point is B, this point is C, and this point is D. The order has changed. Exam में ऐसा ही होगा, दो options होगा. They look everything same except that order will be reversed. So it's starting A, B, C, D. The order got reversed. Please check. Yeah, next one.
Can you go to the previous slide for a bit?
Clear now? Same thing. Can you do this for me? Suppose if I give you VT graph. To V naught, V naught, T naught, to T naught. This is A, B, C, D. Can you draw PV graph? I gave you a VT graph. I'm asking for PV graph. show you. See. This guy and this guy are isothermal things, so they would be like this. This guy is BC, this guy is AD. Be careful, they won't pass through origin. AB and BC, they will be two vertical lines. So the graph would finally look like this. It kind of looks like this. This is A, this is B, C, and D. Those will be two hyperbolas. Clear? These are important questions. They'll ask you graphs.
फिर
A,
AB का volume
B,
ज्यादा है ना?
yeah.
In BC, so the pressure should increase, no?
BC में
Because BC में.
BC में pressure should increase. Why?
Because temperature is the same, volume is decreasing, so pressure.
देखते हैं हाँ तो order change होगा ना when I do this. I wrote reverse. So AB has more volume. So CD has less volume. So what is the common point then? This is A, this is B, C, there. अब increase हो रहा है ना?
Awesome.
Clear na? Got the order right? So they'll give you a graph and they'll ask you to convert it. So you should know how to do this. Next one. Next one. This is a PV graph. A, B, and C. Theoretical question. How is temperature varying on AB, BC, CA? Exam options will be like this. Temperature always increases, temperature always decreases, temperature increases and decreases, temperature decreases and increases. ऐसा 4 options होगा. Get them? So when you go from A to B, is temperature increasing, decreasing, increase, decrease, decrease, increase. Same thing with BC and CA. And I can also ask this, which point is maximum temperature? Okay, that is okay, Arjun. What about temperature and IB, BCCA? No, Arjun, that is wrong. First two are fine, third messed up. Yeah, maximum temperature easy and get the first question. It is not constant. No, Lakshika. Most of you are getting CA wrong, actually. Let's see. Now, first of all, how do you figure out the temperatures? Now, see. Suppose if someone gives you a weird graph like this, any weird graph, I don't care, getting it? And if someone asks you for the temperature, this is how we do. Now, if you draw isotherms, isn't it? So the higher the isotherm, the higher the temperature. The farther the isotherm, farther the temperature. That means you get maximum temperature at which point? When this last point, which becomes, the tangent, when that last point, right, just touches the isotherm, that is the highest temperature, isn't it? Now, coming to our question here, so here, if you see, so anything that lies on that line has a temperature of T1, T2, T3, T4, and T5. So in our question, if you draw an isotherm, there's one isotherm which is passing like this. I agree, A and C have same temperature. Entire line AC won't have same temperature. The next isotherm will be something like this. Then you have one more isotherm like this. Then you have one more isotherm like this. And then you have one just touching here. So this is T1, T2, T3, T4, and T5. So when you're going from A to B, what is happening? So when you go from A to B, you're going from T1 to T5, temperature increases. When you're going from B to C, you're going from T5 to T1, temperature decreases. When you go from C to A, first you're going from T1 to T2, T2 to again T1. So temperature increases and decreases. That is how you figure out. PV is equal to nRT, meaning, I know it doesn't pass exactly, but I should have given data points. You're right, Utsa. We don't know actually. Clear? And obviously, if you see here, the farthest isotherm is T5 and B is there. So B has max temperature. This much we can guess. So anytime they give you any graph and they ask you to temperature, this is what you do.
So why did you add the data?
Yeah, if you don't have data, you can't say it will pass through ANC.
अच्छा,
कुछ भी ट्रायंगल हो सकता है ना, ठीक है. Everyone got this temperature का stuff? So we have ABC like this. N moles ideal gas. Then ideal gas undergoes a cyclic process ABC. Find the maximum temperature in the process ABCA. So when this gas goes from A, B, C to back to A, there will be some point with the maximum temperature. Find the maximum temperature. I'm not asking where, I want how much. .5T midpoint of AB. Who said midpoint of AB? I know you guys will do that. If I had given this as 2V0, then you can say it looks symmetrical. इसलिए मैंने 3V0 दिया. If it was 2V0 now, then you can say by symmetry, the tangent, right, of that isotherm, this AB line will be the tangent. Then it will be the midpoint. There's no symmetry here. It's not midpoint. It's not 1.5T. What is T? What is T? Why are you guys giving me answers and things which I didn't give you? Answer should come in terms of P0, V0, and N. 9, P0, V0, Y, 4, NR. God, you did the same mistake. Palaksh, you took the midpoint. No? How will you do? I'll give you a hint. See. First, find the equation of this line in terms of P and V. And we know PV is equal to nRT. Then substitute there. Then you get temperature as function of volume or pressure. Then do maximum minima. dt by dv is 0. Now try. You can't get it directly. First, find the equation of the line. Substitute pressure in PV is equal to nRT. Get temperature in terms of volume. Then you do maximum minima. There is no other way out. If it was symmetry, your life would have been easy. It's not symmetry. Utsa, that's not right. You did what I said only. Maximum minima kiya tune. इक्वेशन का लाइन इक्वेशन क्या होगा?
अच्छा सर गलत लिखा है, सॉरी सर.
You wrote y is equal to mx क्या?
No, 3v not and I took that as wrong.
तो स्टार्टिंग से वही बोल रहा था, इट इज नॉट 2v नॉट. लेट मी राइट इट डाउन पिक. There 3v नॉट. Everyone loves symmetry. Let's get this. I think highest so far is 265. 95 physics, 95 maths, 75 chemistry. See, so here this is the line equation here. So A ka coordinates will be v naught, comma 2p naught. This coordinates will be 3v naught, comma p naught. So this point is like x1, y1. This point is like x2, y2. So we are using the line equation y minus y1 is equal to slope y2 minus y1 by x2 minus x1, x minus x1. So here basically y ka place mein p is there, y1 ka place mein p naught. 2p naught minus p naught by v naught minus 3v naught. X ka place mein volume is there. So you end up with pressure is equal to p naught minus p naught by 2v naught into v minus 3v naught. You can simplify this, okay? And now we can put them in the ideal gas equation. PV is equal to nRT. Substitute this P there. This will be P naught V minus P naught 2V naught V square minus 3V V naught is equal to nRT. Differentiate. So T will be P naught by nR V minus V naught V square by 2V naught. And minus will be plus 3v by 2. So here changing with volume, dt by dv is equal to 0. This guy will be p naught by nr. That will be 5v by 2. So 5 by 2 minus v by v naught is equal to 0. So v is equal to 5v naught by 2. So at this volume, 2.5 v naught, you get maximum temperature. The max temperature occurs at this volume. And if you see 2.5 v naught is somewhere here. It's pretty close to that B actually. It's not in the middle. So max temperature occurs at this volume. And then take this thing and substitute here there. So T max. So take this guy and put it in this function again. You end up with 5v by 2. Someone did get 25. 25 v naught by 8 nr. That looks right. Clear? That's how you do this thing. If the graph is symmetrical, you're lucky. If this is 2v naught, that will be a proper mains level question. वो तो directly हो जाएगा. So you take the midpoint and finish it off.
So the
If
2
it-
not one came in the empty.
Which one?
So the one with 2v not had come in the empty.
Okay.
So but why can you directly take the midpoint? I don't understand.
Symmetry, na? If this is 2p
Which one?
naught, this is 2v naught, this is p naught, this is v naught. Mathematically, it looks symmetrical. Center में होना चाहिए. That's it. There is no other logic. It's just a symmetry. Right? Max doesn't care whether it is p naught or v naught. Isn't it? Because when you draw isotherms,
Yeah.
it will be in the middle, right? Everyone got this? Clear. Next thing. Any doubts on this? Did you? I hope you guys must have done something like this in chemistry. Did? Graphs, equations, nothing? Okay. Fine. We are doing no props. Let's see. I hope at least they taught you real gas equations. That is there, na? We don't have real gas, so. Let's see. So in kinetic theory of gases, right? So assumptions of an ideal gas or assumptions of KTG. So when you study ideal gases, so there are certain assumptions which make our life easy. So the first assumption, a gas consists of large number of molecules which have negligible volume which have negligible volume, right? And we can assume because the large sample, the gas can be assumed to be homogeneous. That is, pressure, temperature, density are similar or same at every point. This is important. Now, I'm not exactly writing the things. Whatever statement we are writing, we will write some conclusions of that. So exam questions will pop up like this. So let's say if I have a container here, let's say 1 meter cube container. And let's say inside there are 10,000 molecules, right? The 1 meter insulated container. If the number of molecules are doubled, what will happen to the pressure? What do you guys think? You have a container with 10,000 molecules, and if you double the number of molecules, what happens to the pressure? Increases. Increases. So the thing is, pressure and temperature are undefined. Why? The sample number of molecules are so small. If you think about it, in 1 meter cube container, if you keep 10,000 molecules, most of them will be just at one place, isn't it? Most of the space will be empty. It is not homogeneous. Are you getting it? So the number of molecules are very less. So when we say large number of molecules, we are talking about Avogadro number, 10 power 23. We are talking about such a huge number. It should be uniform. Getting it here, the number of molecules are very less. So most of the space is vacuum. There is nothing there. So think of like this. Let's say in your class, 5 10th standard students are sitting, 7 9th standard students are sitting, 3 11 students are sitting, and 4 12 students are sitting. What class is this? You're getting it? It's messed up. It's not defined only. For example, let's say in your room, you switch on the AC. The temperature near the AC is cool. If you go far from the AC, it is more. So what is the temperature of the room? It's undefined, right? You can define if you have one temperature in the entire room. If every point has a different temperature, different pressure, pressure of the gas in a room is undefined. Temperature in the room is undefined. And we don't study such situations. Are you getting it? Here, the number of molecules are very less. So when we say large number, we are talking about Avogadro number. 6 into 10 power 23. That is a type of numbers we are talking about. It should be huge. So be careful with this thing. It's a simple theoretical question, but you'll get trapped. People will think number of molecules double, the pressure will double. Pressure is not defined only. If the number of molecules are very small, therefore most of the spaces are empty. Gas is not homogeneous. Do you remember I told you last time, law of large numbers? You guys remember that law of large numbers I told you? Didn't I tell you? Law of large numbers, right? What it says is when you have large numbers or anything, when something exceeds a certain value, things which are not supposed to happen start happening. For example, let's say someone is planning to learn physics. They solve 20 questions. कुछ होगा नहीं इतना. 200 questions. Okay, nothing much. 2,000 questions. Now game is changing a bit. 20,000 questions. Now you're talking about a different game. You're getting it? Once you do 20,000 questions, you must have literally covered every model at least 3-4 times, 4-5 times. Getting it? The practice between the 200 and this guy, right? This guy will be on totally different level. You must have noticed this, someone who's practicing guitar or violin for 10 years. When they start playing, they play as if it is like nothing, right? They make it look so easy. But when you try to take it to play, it feels like, yaar, kya ho raha hai? Matlab, your hands are slipping. You're not able to put it in the same place. But that person just closes the eyes and just plays it. You give them a tune and they start playing it immediately as if it is normal. It is simply because the number of hours they practiced, right, was huge. Making sense? Actually, this is a strategy which we use. If you see the difference between a topper and a normal student is nothing. This guy just practices n number of questions. Abhi now people who are scoring the 95s, 90s, abhi sab acha lag raha hai. But if you actually think about it, these people from December, Jan, in 2.5 months span, they solved more than 3,000 questions of physics. It's all about that. You think about it. Any chapter that you're strong, you're strong because you solved a lot of questions. Once you solved a certain number of questions, 100, 150, 200, you start actually become confident. And this law of large numbers, right, applies at multiple things. This is a very universal thing. For example, see, right now in our class, how many people are there with the name Arun? Me, right? One. Done. Now, if I say, how many people are there in Mumbai with the name Arun? Now, suddenly there'll be hundreds. Getting it? Once I take the sample large enough, suddenly Aruns became 100. But if I say like this, how many people are there in Mumbai with the name Arun who teach for JE Physics 11th and 12th? Now, suddenly it might reduce. Maybe there might be two more, one more. There might be. We don't know. But the probability suddenly dropped, right? But if I say how many people are there with the name Arun, who's from Andhra Pradesh, who did his study in IIT Madras, who is teaching for Physics 11th and 12th. Now, when I put this many conditions, I'm pretty sure even in Mumbai, it will be pretty rare. But what if we take all over India? Did you see again? Again, it just increase the sample size. You might find someone. You'll find one in Pune. His name is Arun Kumar Sahu. He's my friend. Right? We both studied in 11th and 12th together. He's from Andhra Pradesh. My name is Arun Kumar Sana. That guy ka name is Arun Kumar Sahu. So, we both studied 11th and 12th together. We both went to IIT Madras. We both are in electrical department. My rank was 360. This guy rank was 375. So if you see the alphabetical order, right, H comes first, then N. So iska roll number is EE. EE means electrical engineering 06 2006 batch. B is bachelor degree BTech 005. My roll number is EE 06 B 006. That's how you get roll numbers in IIT Madras. That one thing will tell you full history. Your batch, which branch you are, which batch you are. Either you are, if you're MTech, it will be M. If you're a PhD student, it will be S. And that's your roll number. After that, I became a teacher. This guy joined in Tata Steel, and this guy did some nonsense. Then he came out from there. He forgot to complete a course. So this guy didn't take a degree for 6 months. Oh, alag story. I'll talk about it later. This guy, we call him delay circuit actually. He keeps forgetting stuff. And then I brought him to Mumbai. I trained him for 2 months, and then we sent him to Hyderabad. There he worked as a teacher for 2 years. Then he joined in PACE Pune. And now he opened his own institute. So, and this guy is also a physics teacher. Now see, suddenly that thing, right? You will find one guy, at least one guy that I know of. So this is what I mean by, law of large numbers. When you have a large numbers, things can happen. There is an estimate. If you travel a distance of 10 power 28 meters, which is actually quite large, you can find a planet called Earth. In that planet, there's a country called India. In that country, right, there someone is teaching a physics class. Getting it? Where I am the student and Swastika is the teacher. Or maybe I am there, but I'm teaching chemistry class right now. So the probability, when you go such a large distance, any kind of weird event is possible within the rules of science, physics. It has to obey laws. It is like this. So there is something called law of large numbers. Keep that in mind. It's quite useful. A company which is selling 1,000 packets of something, a company which is selling 1 crore packets of something, there's a huge difference. The 1 crore packets ka company, right, can produce it in bulk. You'll get cheap. Kabhi dekha DMart mein why onions are cheap? Next time observe karke dekho. DMart mein you'll find everything little cheaper than outside. That's why people love to go to DMart and buy in bulk. Because whenever DMart buys, what it will say? It will go to the farmers and say, I want 30,000 tons of onions. It won't say mujhe 30 kg chahiye. I want 30,000 tons of onions. Please grow them in next 3 months. He'll give the advance and go. He doesn't buy onions. He'll make the onions grow. And because of that, he gets onions for 10 rupees. He sells you for 15 rupees. Bahar market mein, you'll get the same onions for 25 rupees. That's why DMarts are always in rush. That simple reason, he buys in tons. Can you imagine buying 50,000 tons of rice? In the house, you buy 50 kg rice, तो वो आएगा 4-5 months आएगा वो. So that way. Clear? This is the first assumption there. So the main thing is the sample should be large enough. Second thing, molecules do not have any preferred direction. Means there is nothing like I want to go in this direction. They just go randomly. Motion is completely random. So basically, this is what we call as Brownian motion. Since the motion is completely random, the average displacement will be 0. The molecule is going like this. Eventually, it comes back. Average displacement is 0. Therefore, if average displacement is 0, average velocity is 0. So when you're studying a gas, right, if average velocity is 0, it's actually of no use. You're getting no information there. So what people said, yeah, this is useless. We need something more to define energy. That's where you get Maxwell distribution of velocities. I hope this you studied in VRMS, V probable. Studied that? Chemistry, mein?
Yeah.
Yeah. So we will not derive all that. We will write it down. I'm combining the KTG with this thing and I'm teaching all together because you guys already know this thing. So Maxwell distribution of this thing. So this is NV. This is simply number of molecules at a given speed. So what is this speed here? V probable, V mean, and V RMS. This thing, right, is also called as bell curve or normal distribution. Again, this is one of the most prominent graph in day-to-day life, meaning you will literally see this in everywhere. Again, law of large numbers. If you take the height of every person in the country and if you try to plot the heights versus the number of people, you'll observe there are very few people with height of 7 feet and 8 feet and all stuff. Again, there'll be very few people with the height of 1 feet and 2 feet. We're talking about adults. You will find most of the people will lie in the range of the 4.5 to 5.5 or 5'7", whatever. So the bulk. If you plot all people ka JE marks versus number of people, you'll find the same thing. There'll be very few people with 290s and 270s. Most of the bulk will be around 120 to 150 ka range. That is the reason if you score 170, your friend scores 171. Let's say example, your rank is 9,000. Your friend ka rank will be maybe 8,800. But if you score 120 and your friend scores 121, right? If your rank, let's say, is 40,000, your friend ka rank might be 33,000. That 1 mark may you lose almost 4,000 ranks. I might have exaggerated it, but let's say 36,000. You get a huge difference. Simply because there's such a huge number of people in that thing there. So V probable is the speed possessed by maximum number of molecules. We don't require that equation and all that Maxwell equation. We don't have that. You should just have this. Speed possessed by max number of molecules. What is the formula? Root over 2 RT by M. This you have to remember. M is molecular weight in kgs. V mean is your average speed. Which is 8 RT by pi M. VRMS is root mean square. We'll talk about this in more detail. 3 RT by M. You need to remember these formulas here. In a symmetrical curve. Yeah, right with it.
So we don't have Maxwell's function.
Yeah, we don't have that function. Okay. You should just know these formulas there. That function, I don't know. Maybe chemistry mate is there. Physics maybe we don't need it.
Yeah, because in base that guy taught it.
We don't require waste of time. We'll never encounter that. Clear with this? So what is this VRMS exactly? Now, for particles, if you take individual particles, V mean is simply V1 plus V2 plus so on till Vn by n. Vrms will be v1 square, v2 square, so on till vn square by n curve root. But if you have a Maxwell distribution, the v mean will be integral v dn by integral dn. Vrms will be integral v square dn by integral dn curve root. Clear? And basically in this graph, right, if you take this area under the graph, integral nv dv, this gives you the number of molecules from 0 to infinity. This gives you the total number of molecules. Because this is the number of molecules at a given speed into speed will give you total number of molecules. We'll see a question based on this later on. Clear? Take a break. Come back by 7:02. We continue from here. Any doubts so far? Anything not clear, please ask me.
So can I just send you a method of that calorimetry and can you check if it's right?
Bejo.
That's fine.
Others take a break. Come back in 7:02.
So basically, all the excess heat is used for converting the ice to water at that temperature. And then I did the equilibrium thing
Same
once
thing.
again.
Yeah, you did the same thing. Same.
Okay, fine.
We did it in little more systematic. You did the same thing, but we just wrote it on a
Okay.
paper. You didn't write it.
Thank you.
Chalo, come back by 7:02. Third point. Chalo, cams on everyone. The collision between molecules and with the container walls is perfectly elastic. The molecules obey Newton's laws of motion. The effect of gravity on the molecules is negligible. Cams on everyone. The molecules travel in straight lines. The time interval between collisions is negligible. There's some of the things, based on all this, right? There is a proof for proving PV is equal to nRT. We don't need it. It is only for HSE ka derivation. It's not that important. So we'll not do that. It's a waste of time. We'll focus more on problems than that. We take one molecule in a box and then we find the change in momentum force and we'll prove PV is equal to nRT from that. It's of no use. Trouble between collisions. So these are some of the things. There's one more point here. Molecules do not interact with each other. Except during collisions. Means there's no force of attraction between them. Therefore, so this point, right, ideal gases cannot be liquefied. Because there's no force of interaction between them, the gas molecules will never become this thing, into liquid form. Why will I stop obeying Newton's law of motion? Laws of motion has nothing to do with that. If there's a molecule moving with speed, it will continue to move, right? Clear with this? So from all these points, right, we can differentiate between few points between ideal gas and real gas. So if you take ideal gas, you can get theoretical questions on this. The first thing, the potential energy between the molecules is zero. Since interaction between molecules is negligible. Therefore, the internal energy of a gas technically speaking, it should be potential energy plus kinetic energy. Since potential energy is 0, kinetic energy is the internal energy. Whereas in a real gas, potential energy is not 0. Molecules do interact. Second thing, this ideal cannot be liquefied. Real gases can be liquefied. The ideal gas equation is PV is equal to nRT. The real gas equation is P plus AN square by V square V minus NB is nRT. So this A here, it tells us about interaction between molecules. So A is based on, takes care of interaction between molecules. This B is the size of the molecules. So A and B, right, they play two different roles. Whereas in ideal gas equation, if you look at this V here, in PV is equal to nRT, what is V exactly? If someone asks you PV is equal to nRT, what is V? What is V exactly? What do you guys think? V is not volume of the container. V is actually the volume in which the molecules can freely move. That's why see here what happened. So when you take V minus NB, NB is the size of the molecule, V is the volume of the container. So the molecules can freely move in V minus NB now. Are you getting it? The space occupied by the molecule, that space you can't move. So V is the volume of the container, NB is the volume of the molecules. But here in ideal gas, size of the molecules is negligible. Since size of molecule is 0 or negligible, V becomes the volume of container. So, but theoretically, if someone asks you what is V, it is not volume of the container. It's a volume in which the molecules can freely move. That's the reason you're getting V minus NB in the real gas equation. That much basic idea I have about real gas equation. Clear? Next thing. Now, based on these, if I give equal amounts of heat to ideal gas and real gas, who will have more temperature? They can ask a question like this. Is given to ideal and real gas in a closed insulated container. Matlab volume can't expand, work done is 0. In a closed insulated container. Who has more temperature? This is a good one. Got the question? You took an ideal gas, you took a real gas, kept them in a container. So this KTG, if you see, there are two parts. One questions will be based on mechanics. One is all this theory only. Mechanics question we'll see. We'll get all springs, pistons. I know you all are missing springs. Not missing springs. Now see, what happens, I'll tell you. It's not straightforward actually. In ideal gas, whatever heat that is supplied, everything will go into change in kinetic energy. Fair enough. For real gas, the problem is whatever heat you supply will go for change in kinetic energy plus change in potential energy. Now there is a problem here. At low pressure, what will happen? Molecules are far, right? Then that means there's a van der Waals attraction. At low pressure, molecules are far away, so there's an attraction. Remember, thermal expansion, I wrote that graph. Molecules are far, so therefore forces are attractive. Getting it? So molecules basically attract. At high pressure, what happens? So in this case, potential energy is negative. At high pressure, because you're keeping the volume constant here, you're pushing the molecules against each other so much. Molecules are too close, they start repelling. Potential energy is positive. So, and we know temperature does not depend on total energy. Temperature depends only on the random kinetic energy. Or in this case, kinetic energy only. So this is what happens. Ideal gas temperature rises more for low pressure compared to low pressure real gas. Because if the pressure is low, the potential energy is negative. So whatever energy you're giving, it will go for potential energy, isn't it? That will absorb. Kinetic energy will be less. So compared to low pressure real gas. Is less. But if you give it to a high pressure one, already it is under very repulsion. You give more energy, the energy, most of the energy will go into this kinetic energy. The potential energy also becomes kinetic energy. The molecules will bounce much more. So who will have more temperature will depend on the pressure of the real gas. Making sense? If it is negative, whatever energy you give, the system will absorb, so kinetic energy will decrease. But if you put high pressure, potential energy is also positive. On top of it, you're dumping more energy. Systems will repel more. Kinetic energy will bump up. So temperature will rise more. Have a look at this. Clear? Now, there is a question like this, a theoretical question. For a real gas to behave as an ideal gas, what is the condition? Low pressure, low temperature, high pressure, high temperature, low pressure, high temperature, high pressure, low temperature. These are 4 options. I can write that thing here. A real gas behaves like an ideal gas at low pressure or high pressure. At low pressure, you want the molecules to be far away so that interaction is less. And high temperature, you want them to go so fast they do not have only time to interact. That will be a good theoretical equation. This was kind of like this. This is a question which will ask in bits and stuff. Clear? Next thing. This one.
Yes. Thank you, sir.
Next thing. Degrees of freedom. Symbol is F. This, if you remember, we did this in rotation, maybe discussed a bit. The number of independent directions in which a body can have motion. Or a system can possess energy. So we have something called law of equipartition energy. This law says the energy associated with each degree of freedom, whether it is translation, rotation, vibration, doesn't matter. Is equal to half k T for a molecule. K is called Boltzmann constant. Which is gas constant by Avogadro number. Here R is 8.314 joule per mole Kelvin. You have to use this, and N is your Avogadro number. Therefore, a total energy of a molecule will be F times half kT. Therefore, total energy of a gas the total energy of a gas will be total number of molecules. That will be N into Avogadro number into F by 2 kT. So that would be N F by 2 into RT. Small n is the number of moles. So number of moles into Avogadro number will give you number of molecules. Number of molecules into energy per molecule will give you total energy. This is total number of molecules. So for a gas, the formula becomes F by 2 nRT. I think you should note down this thing. So for a molecule, it is F by 2 kT. For a gas, it is F by 2 nRT. Clear? This now you can also actually write this thing as PV is nRT. We'll do it in the next page. Now see, for monatomic, the molecule only goes in Vx, Vy, and Vz. Now there'll be one self-rotation also. This is negligible. Why? Since the size of the molecule is 0, for an ideal gas, the moment of inertia 2 by 5 mr square is also 0. Therefore, the kinetic energy R5 omega square is also 0. So that will not have any component. So therefore, F is equal to 3, and all three are translation only. So if you think about it, monatomic also can rotate about itself, right? But that is negligible because you're taking an ideal gas, the molecule size is 0. So you don't consider that rotation. So you have 3 translation for monatomic. If you take for diatomic, you have Vx, Vy, Vz. We have this rotation. We have this rotation. We have this rotation. Again, this is negligible. If the axis passes through the molecules, size is 0, moment of inertia becomes 0. So we have 2 rotation components and 3 translation. So for diatomic, 5 will be 5. But at high temperatures, the 2 molecules, right, will start oscillating. The molecule vibrates something like this. It becomes like a spring. So there is an oscillation now. So we get 2 degrees of vibration. So vibrational potential energy, vibrational kinetic energy. Generally, high temperature meaning 500, 600, they'll mention. So in that case, F will be 7. So at high temperature, diatomic has 7 degrees of freedom. At low temperature, it is 5. Clear? Now for triatomic and all, it actually depends on a lot of things. So there is a table in NCRT. We will just mug it up. And they did ask questions from the table directly. I'll show you this again in thermodynamics, but for now, let's use this. This is there. So if you take monatomic, if you see translation, rotation, vibration, rotation 0, translation 0, so 3 degrees of freedom. CPCV, don't worry about that. That I'll show you in thermodynamics. If you take linear triatomic, then you have 3 plus 2, so basically F is 5. F is 3. Triatomic non-linear, F is 6. Diatomic with 1 vibration mode, triatomic with F vibration mode. So I think this is the most important thing to remember. Where the degrees of freedom will be this guy will be 6 plus n, where n is the number of vibrational degrees. Remember the triatomic thing. Remaining all are actually kind of nonsense. You don't require. If they don't mention anything, we take triatomic with F vibration mode. This was asked in the exam mains. They said there's a triatomic gas with 2 degrees of vibration. Find the gamma of the gas. Gamma, we will see in thermodynamics what it is. So it'll have 3 degrees of translation, 3 rotation, and F degrees of vibration. Actually, wait, this is 2n. Six plus 2n. Because if you see the formula, what he's doing here, he's taking half here. He is taking only 1 here. So basically, this is actually 2 by 2. So each vibration degree will have 2 components again, one vibrational kinetic energy, vibrational potential energy. In this formula, he's just considering as 1 into kBt instead of 2 by 2 kBt. So it is 6 plus 2n. Be careful there, not 6 plus n. Clear? Each vibration mode has 2 degrees. Vibrational Ke, vibrational Pe. So this is the table. I would say mug up this guy. This is the most important one. Baki sab theek hai. Clear? Now, a few questions on this. If they ask you average vibrational degree of freedom, the formula would be N1 F1 plus N2 F2 by N1 plus N2, where N is the number of molecules. Suppose if a gas is restricted to a 2D plane, this will be a theoretical question. Matlab, it can go only in 2D plane, not 3D normally. Can you tell me how many degrees of freedom will monatomic and diatomic have? Normally gas molecules are in 3D, right? What if they can be only in 2-dimensional? Monatomic ka, right, Utsa. What about diatomic? Right. This will have two. Both will be translation only. You can go only in two directions, Vx and Vy. Since you're going in a plane, Z is eliminated. This will have three. Vx, Vy, and rotation in XY plane. We are ignoring vibration. So two translation and one rotation. Clear? And if you see this thing, so PV is equal to nRT. So I can write this thing as three by two nRT. This becomes kinetic energy translation. 3/2 PV, or you can write 3 into half nRT. Basically, each component gives you this. This gives only the transition kinetic energy. Here, there is nothing important. We wrote this before. Temperature depends only on. See, first of all, think about it. Temperature depends on what? Collision between molecules, right? Now, will collisions happen due to rotation or translation? Translation. So, temperature depends on random kinetic energy, agreed, but usme bhi random translational kinetic energy. This is quite an important thing. That means if you take a diatomic and monatomic, in monatomic, if you give same heat, monatomic, right, the temperature will be less because it will take some of the energy and give it to rotational components. We will see a question on that. But keep this in mind. Temperature depends only on transitional kinetic energy. It does not depend on total kinetic energy. Clear with this? Let's say I'll ask a question on this. Bit of a theory. Going ahead. So these questions are good. Listen carefully. Actually, now let me complete one more thing here. We did right here, but I'll just add it up here. Wait. So basically, let me write it again. So kinetic energy of a molecule is F by 2 kT. Kinetic energy of the gas is F by 2 nRT. Since the internal energy is kinetic plus potential, but potential is 0, which is F by 2 nRT. So internal energy of a gas is F by 2 nRT. Keep this in mind. Whereas kinetic energy translation for a molecule is 3 by 2 kT. Total is F by 2 kT, but translation is 3 by 2 kT. There. So internal energy of a gas is F by 2 nRT. We wrote that energy of a gas, same thing. Let's see a question on this. Turn the page. So we have two containers. We have helium, we have oxygen. Let's say this is N1 moles. This thing is N2 moles. Both of them are given same heat. Find ratio of kinetic energy of helium by kinetic energy of oxygen, translational kinetic energy of helium by translational kinetic energy of oxygen, temperature of helium by temperature of oxygen. I want the ratio. N1 moles, N2 moles, helium, oxygen, both are given same heat Q. Okay, 3n1 by 5n2 remaining. What is the first answer? First one, see. 1:1, na? Why? Whatever energy you are giving, where will it go? The energy supplied Q should go to complete kinetic energy, F by 2 nRT, isn't it? Whatever heat you supply will go to kinetic energy plus potential energy. Potential energy is 0, so this goes to kinetic energy. So that means kinetic energy of the gases is Q only. Fair enough? It will be same. Why does it matter? 1:1.
फिर F का क्या हुआ फिर?
F का कुछ नहीं हुआ.
तो contradicting नहीं हो रहा.
Contradicting कुछ नहीं है ना. देखो ना, temperature, who said temperature is same? Who said temperature is same? See, logic ये है. There are 1,000 people here. There are 10 people here. I gave them 1 lakh. I gave them 1 lakh. How much money do they have? 1 lakh, right? Who cares how many are there? समझ में आ रहा है? So the first one is 1:1. What about the second guy? Now, whatever energy you're supplying for the helium will do what? It will give Q by 3, Q by 3, Q by 3 for translation. This is what the helium will do. You have 3 translations and it will divide equally. Remember law of equipartition energy. All the energy will divide equally between each degree of freedom. What will the oxygen do? Oxygen will divide into Q by 5, Q by 5, Q by 5, Q by 5, and Q by 5. So we have 3 translations and 2 rotations. Now, I don't care about the number of moles, all that is nonsense. So that means this guy will be Q, this guy will be 3Q by 5. This is 5:3, na? You guys assume temperature is same and solve the problems. Nahi? Dekho, 1:1 and 5:3. Check. Why do I care how many moles are there? Whatever you give me, I will divide equally between them. Yes? Temperature कितना होगा अभी? Our temperature will depend. Temperature is what? Kinetic energy translation. Now you can write basically. So Q is equal to F by 2 nRT. So F and T is constant. So T would be Q by. So temperature is proportional to 1 by F and N. So for oxygen, F is 5 and number of moles are N2 and this guy is 3 and N1. That's your answer. Clear? Temperature same नहीं है. Clear? Understood this question? Easy one, but you have to be careful. Let's see one more like this. Turn the page. Similar thing, helium gas, N1 moles. People think you have to use N1, N2 somehow. Oxygen, N2 moles. They have same temperature. We are doing reverse. Now find ratio of kinetic energy of helium by kinetic energy of oxygen, kinetic energy of helium molecule by kinetic energy of oxygen molecule, kinetic energy of helium molecule translation by kinetic energy of oxygen molecule translation. Get them? They have same temperature. What is the first answer? Kinetic energy is nothing but F by 2 nRT. You're saying temperature is same. So kinetic energy is proportional to Fn. So this guy would be 3n1 by 5n2. Kinetic energy of helium for molecule is F by 2 kT. K is constant, T is constant, so it is proportional to F. 3:5. Kinetic energy of a molecule, and you're asking only for translation. Now, if you're just asking only for translation, it is always 3 by 2 kT. Doesn't matter which molecule take. 1:1. Right, Anika. Check. Getting these questions, they're not tough, but you have to be careful what you're talking about. Or translation, rotation, components, and all. The previous one was like a trap. People will think kinetic energy N1, N2 sub डालना है. So if you're not careful, you'll goof up. हाँ, Maulika, clear ना? Got this? Neil, Aditya, Aryan, Palaksh, Arjun, Vartika, clear ना? Vidyut, Yasha, clear? All clear with this? Let's see one more. Last one for the day. We have two insulated containers. Next class, we'll do some good problems. Next class, we'll wrap up KTG. We'll start off with Thermo introduction. We'll do more problems, more varieties in Thermo. So insulated containers, P1, V1, T1, this is helium gas. So in the middle, there is some tap. This is P2, V2, T2, hydrogen gas. Now the tap is opened and the gases are mixed. Find the final pressure and final temperature. Just get me the equations. How do we write this? When you mix up finally, like I said, always, if you know how, you should always know how the final diagram looks like. Not only in mechanics, even in thermodynamics, you should know how the final situation looks like. So if you mix this up, how will the final diagram look like? This will become pressure P dash, temperature T dash, pressure is P dash, temperature is T dash. Pressure and temperature will become same, right? If the pressure is not same, the gas will keep flowing till the pressure is same. If the temperature is not same, the heat will keep transferring till the temperature is same. So finally, both the containers will have same pressure and same this thing. Now, can someone tell me what is constant here? Yep.
Volume.
Volume is constant, ठीक है. What else?
Number of moles.
Number of
Number
moles.
of moles, right, Yasha? Right, Utsa. Number of moles, partial pressure नहीं है. With you're right. Energy is also conserved. So first thing, what you do, conserve number of moles. इसमें कितना होगा? N1 will be P1 V1 by RT1. N2 will be P2 V2 by RT2. So this guy will be P dash. Volume will be V1 plus V2. This will be N1 plus N2 RT dash. There are two variables here, P dash and T dash. We have one equation. Second equation comes from energy conservation. So what is initial energy? Helium, na? So F helium, N helium, R, F by 2 N R, temperature of the helium plus F oxygen by 2 N oxygen, R, temperature of oxygen. Finally, F helium by 2 N helium, R plus F oxygen by 2 N oxygen, R, T dash. Actually, T dash you'll get it very easily. एक बार T dash आ गया, put it here, you get P dash. You got everything. Take it out. Temperature you directly get from energy conservation, one step. Then use PV is equal to NRT and get pressure. If helium is 3, N helium is this N1. This guy is T1. This guy is 5. This guy is N2. This guy is T2. Substitute कर लो हो जाएगा. Clear? I'll give you homework question. Try this and come next class. We have a container. We have a piston here. We have a piston here. This is 1 meter. This is 1 meter. In the middle, you have a spring. This is vacuum. This is 1 mole. Temperature is 300 Kelvin. This is also 1 mole. Temperature is 300 Kelvin. So this is the initial system, right? And spring is compressed by 1 meter. This is the initial data. Container is insulated. So initially spring is compressed by and then what happened? Same scenario, but this time someone This side they made the temperature 400 Kelvin. And this side the temperature they made it 500 Kelvin. So you just increase the temperature on both the sides. Maybe you gave some heat from outside, whatever, doesn't matter. This information is there. So the temperature on the left container and right container are increased to 400 and 500. Pistons are massless and smooth. Okay? Find the new compression in the spring. So initially it is already compressed by 1 meter. So additional or extra kitna compress hoga basically. Try this and come. Next class we'll discuss first thing in the class. This is purely ideal gas equation and force equations. There is nothing else. इसमें energy कुछ नहीं है. आंसर कुछ √13 ऐसा कुछ आएगा. I don't remember exactly, but ऐसा कुछ है. Question is clear. If I give 300 Kelvin, whatever gas is there, the spring will be 1 meter compressed. But if I give 400 and 500, whole thing gets messed up. Something happens. Meaning this distance also won't be 1 meter. I don't know what will this be. Nothing is given. The question is, what is the final compression in the spring? Clear? Try this. Friday, first thing in the class, we will be discussing this. Spend some time. This will take at least 15-20 minutes. Arams it will go. Take some time and do it. Because when we do it in the class, we will finish off in 5 minutes. But I want you to think a bit on this. Okay? So this is the kind of questions we will see in the next class. And mostly next class, we will wrap up this. And maybe we'll start thermodynamics ka little introductions. Okay, we'll wrap up with this. Rotation ka test is online till tomorrow night 11. So do make sure to give. So any doubts, anything in today's class, anything else, please ask. Also free to leave.